As a team passionate about environmental sustainability and innovation, we embarked on a project to design, build, and test a customized boat that could collect water quality data from various locations. Our goal was to explore and understand the environmental conditions of local water bodies using modern technology. The boat was equipped with a temperature sensor and a RunCam Nano 2 camera, which allowed us to gather valuable environmental data while autonomously navigating different areas of the lake. The RunCam Nano 2, although originally designed for FPV drone racing, was chosen for its lightweight design, low power consumption, and ease of integration into compact systems. While its image quality isn't perfect, it provides a relatively basic analog video feed. It proved to be more than sufficient for our purposes. The camera allowed us to visually monitor obstacles, assess the boat's immediate surroundings, and identify areas where the boat might shatter or get stuck, such as near reeds, rocks, or docks. Beyond its technical capabilities, the boat also stands out visually, thanks to a thoughtful and symbolic design. It proudly displays the Lithuanian flag, celebrating our national identity and reflecting our commitment to global environmental responsibility. Our team logo and distinctive leaf motifs further reinforce our mission to develop sustainable, eco-conscious technology that respects and protects natural ecosystems. To enhance visibility and ensure operational safety, especially during low light conditions, we installed bright white LED strips around the boat structure. These LEDs not only help distinguish our robot ship from other vessels, but also allow observers to track the boat's position during night operations or cloudy weather. For added durability, we carefully isolated the LEDs and internal wiring with waterproof sealing, protecting the system from potential water damage and ensuring consistent performance in wet environments. We tested our boats at Žalieji ežerai, a scenic lake area surrounded by nature. This was not only a technical trial, but also a fun and collaborative event. We even took part in a friendly boat race among our teams. Of course, the process came with its challenges. Some of our 3D printed parts broke, and at one point, one of the boats stopped moving. Thankfully, teamwork saved the day. My friends jumped in to rescue the stranded boat. We quickly replaced the broken parts, and the boat was back in action. We also lent a hand to another team whose boat wasn't working, showing the true spirit of collaboration. Throughout the testing, we used temperature sensors to gather readings from various parts of the lake. This data was saved onto SD cards for later analysis. After our fieldwork, we created a GIS map to visualize the temperature variations across different parts of the lake. The results were fascinating. We observed that shaded areas were cooler, while sunlit regions had higher temperatures. This not only validated our sensors' effectiveness, but also gave us deeper insight into how sunlight and shade affect water temperature. As part of our ongoing environmental research project, we created a comprehensive GIS-based data visualization platform that translated raw temperature data collected by our robotic boat into a clear, interactive, and visually engaging format. The GIS map was created using QGIS and includes multiple environmental parameters. To represent air temperature, we used a warm color gradient. Higher air temperatures are shown in deeper reds and oranges, while cooler air temperatures appear in lighter reds or white. For water temperature, a distinct blue gradient was applied. Warmer water areas appear as lighter blue, while cooler zones are shown in deeper, darker blues. In addition to temperature data, our GIS visualization also includes dissolved oxygen level readings. Here, the color scheme is based on oxygen concentration. Values above 9 are visualized with warm colors, such as yellow, indicating well-oxygenated areas, while values below 9 are shown with cooler tones such as blue and green, highlighting areas where oxygen levels may be lower and potentially less favorable. One of the clearest and most informative patterns we observed was the temperature difference between shaded and sun-exposed areas. The data consistently showed that shaded areas, such as those near trees, under bridges, register lower temperatures than areas fully exposed to sunlight.
As part of the Sailtunities hackathon, under the motto "We are the voice of water", we set out to answer an important question: what does the chemistry of our water reveal about the environment we live in? As chemistry students, we took on the responsibility of analyzing water quality with scientific accuracy. In our school's laboratory, we conducted a series of chemical tests on water samples. We began by searching for common heavy metals, such as iron and copper. Using test strips and reagents, we found no trace of these substances, 0 mg per liter, in all samples. This was an encouraging sign of minimal industrial contamination. Next, we examined chloride levels, as well as nitrogen-based compounds, specifically nitrates and nitrates, which are often indicators of agricultural runoff. Once again, the results were promising. Nitrates and nitrates measured 0 mg per liter, while chlorides were very low at just 2.5 mg per liter. We were also curious about the pH and alkalinity of the water. The pH was slightly acidic at 6.5 and the alkalinity was higher, 200 mg per liter. This suggests the presence of natural buffering substances like carbonates. While unusual, this isn't harmful and might even reflect healthy, good geological conditions in the region. During the boat races, we made good use of our time by conducting additional tests for zinc, tin, ammonium, and phosphate. All results came back at 0 mg per liter, showing no alarming signs of nutrient pollution or urban runoff. The pH results were also confirmed by a pH sensor, which validated our measurements during testing. In conclusion, our data tells a clear story. The water is clean, safe, and chemically balanced. This reinforces the idea that with proper environmental care, our rivers and lakes can remain healthy and resilient. We are proud to be the voice of water, and the science backs us up.
This project is just the beginning of our journey into environmental monitoring and green engineering, and we hope it inspires others to explore, create, and protect our planet through innovation.